Hi, my name is Ezra Webster. This is my presentation on identifying a specific organic compound based on chemical formula and multiple spectral analysis. The compound I was assigned has the formula C10H12O1. And beginning with the infrared spectral, we can see that at about the 1700 range, we have a large peak which would indicate the presence of a carbonyl group. Just above that, in the 17 to 2000 range, we have a series of peaks which would indicate the presence of an aromatic or benzene ring. And closer to 3000, we have a peak which would indicate the presence of carbon-hydrogen as in an alkane group. Moving on to the C13 NMR, we have at about 210 a peak which would indicate the presence of a de-shielded carbon, such as a ketone or an aldehyde. And then between 120 and 140, we have a series of 5 peaks which would indicate sp2 carbon-carbon bonds. That would indicate something like a benzene ring with a functional group attached. Finally, in the proton NMR, we see at about 7.2 a peak with an integration of 5, which would indicate 5 singlet hydrogens. We also have at about 3.75 a peak with an integration of 2, also singlet. At about 2.5, we have peaks with an integration of 2 and a multiplicity of 4, meaning the quartet. And we also have at 1 a peak with integration of 3 and multiplicity of triplet. In summary, what we've seen in the infrared is an indication of a carbonyl group at 1700, very large peak there. Just downfield of that, at 1800 to 2000, we have peaks which indicate the presence of an aromatic or benzene ring. And at 3000, we have a peak which would indicate carbon-hydrogen bonds as in an alkane group. In the carbon-13 NMR, we see at 210 a peak which indicates a de-shielded carbon, such as a ketone or an aldehyde. At 120 to 140, we see sp2 hybridized delocalized pi bonds, which would indicate the presence of a benzene ring. We also saw 5 peaks there, which would indicate the benzene ring has an additional group attached to it. And in the proton NMR, at chemical shift of 7.2, we see 5 hydrogens with a singlet multiplicity, which would indicate 5 non-unique proton groups like on a benzene ring, with an additional functional group attached. Otherwise, it would be 6H. At 3.7, we see 2 hydrogens with a multiplicity of singlet, which would indicate that there could be a carbon with 2 hydrogens between a benzene ring and a carbonyl group, as we saw up above. At 2 to 3.5, we see 2 hydrogens with a quartet multiplicity, which would indicate that that could be a carbon with 2 hydrogens bonded to a carbonyl group and a methyl group. And at 1, we see 3 hydrogens with a triplet multiplicity, which would indicate a methyl group bonded to a carbon with 2 hydrogens, which aligns very well with everything else we've seen. Notably, what we don't see in the proton NMR is any evidence of an aldehyde hydrogen, which means that our carbonyl group has to be a ketone and not an aldehyde. With all this information in mind, we can start piecing together our final molecule. We can start with the degree of unsaturation calculation. We have 10 carbons times 2 is 20, minus 12 hydrogens would make 8, plus 2 is 10, divided by 5, or 2 equals 5. That indicates that we have our benzene ring, which is really a phenyl group, which has a degree of unsaturation of 4, and a carbonyl group, which has a degree of unsaturation of 1. From there, using the rest of our evidence, we've seen a lot of evidence that there is in fact a benzene ring, and we've seen evidence that there is a group attached to the benzene ring, making it really a phenyl group. So we can start with that. We know that there's a carbonyl group because of our C13 spectra, and we know that there is a carbon with 2 hydrogens between the benzene ring, and the carbonyl group, which we've indicated here. We know that the carbonyl group is not an aldehyde because the proton NMR did not show any evidence of an aldehyde H. So we know that it's a ketone. We also know that there is a methyl group because of our proton NMR showing a integration of 3 with a triplet multiplicity, which indicates that there is a methyl group next to a carbon with 2 hydrogens. And because of that, my finding is that this molecule is 1-phenyl 2-butanone. One phenyl, 2-butanone.